I want to welcome all of you today to probability distribution. This time, normal distribution. Who can remind us of the other distributions we have looked at already? Who can raise a hand and remind us? Anybody? Do you remember any of the distributions we've looked at so far? We've mentioned quite a number of them. Eileen?
Binomial distribution.
Binomial. Clement?
We looked at the Poisson distribution.
Poisson. What else? Is that all? There were other distributions we mentioned. We didn't examine them in total. Who can tell us? Some of them. Kwache?
The uniform distribution.
Uniform. Millicent?
Exponential distribution.
Millicent, I think you have a challenge with your mic.
Exponential distribution. Sorry.
Exponential distribution. Very good. Let's start with normal distribution. Okay. You should understand it by the time I finish it too. And you should understand it in total, not just the usual way. Normal distribution is a continuous random variable. It's used for assessing the continuous random variable. A continuous random variable is any variable that can take any value in an interval. So you are dealing with a collection of intervals. It can have decimals. That's what we said the last time. You can't talk about probability distribution being a continuous random variable when you are assuming a particular value. No, you can't assume a particular value. So the probability of x equal to 0 is what we mean. It can't happen. It can't happen. So what should happen? We rather speak of the probability of the continuous random variable assuming a value within a given interval. And that is why the cumulative distribution function is given as a probability of x, the random variable, less or equal to one specific value you are looking for. And here's the point. Not equal to 0, but for all x, which is a member of is one of the real numbers or one of the random variables. So it is a range. It's a range. The other thing is that, like any other distribution, you should be able to identify the mean and then the variance of a continuous random variable. And once you know that, you can identify the density function. Because remember, the expected value is the mean. And this is given as the integral of negative infinity all the way up to positive infinity, where x is multiplying the distribution, okay, the function. Most of these have already been calculated, so you don't need to bother yourself. The variance is also given as this function that you see. It's just a difference between the first one and that of the expected value. We've already looked at these. In fact, we gave an example of a distribution called x, and then there is probability, a random variable called x, and it's different values of probability distribution. And what we were doing was to pick each particular random element and multiplying it by the respective probability. Let's take a typical life. This is a very practical, typical life for you to begin to appreciate what a normal distribution, before we even define a normal distribution. So let's look at the heights of some female college students in Midwestern College. They have an enrollment of 3,264 female students. And on the right here, you can see the height of each girl, the frequency of how many girls have a height of between 56 and 70. That is between 56 and 57. How many girls have a height of between 57 and 58? There are 6. And based on these frequencies, we can compute the relative frequency. We can take each of these elements divided by the total, which is 3264, and we can calculate the relative frequency for each one. And you can see, when you look up here, you can see that the biggest value is 557. And no wonder it is the one with the greatest relative frequency. So with that in mind, let me just quickly ask you something. What do you think is going to be the relative frequency that the students are between 60 and 69 inches tall? What will you do? Who can tell me? Yeah, in other words, what is the relative frequency, this far right, that the students I'm going to pick, some of these students are between 60 and 68 inches tall? Who can tell me how to compute that? Or what would you do? Basically, what will you do? Yes, Kwachi.
Add the relative frequencies between the 60 and the 61 all the way to the 67
So
and
give
the
me these
60,
relative
68.
frequency. Give me the first and the last one.
The first one is 0.045.
Mhm.
The last one is 0.0735.
Excellent. So between those two numbers, what do you do?
I'll add the relative frequencies.
Exactly. So guys, he's talking about this. You take this one, add all of them up to that one there. You add all of the relative frequencies, and that will give you the relative frequency that a particular or the group of students are between this number and that number. Very good. In fact, that has been executed here. You can see that I've used the arrow, the red shaded box, to depict those. The next question is, what is the relative frequency that the students are shorter? Write them down, write everything down. The students are shorter than 68 inches. What is going to be the relative frequency? The students are shorter than 68 inches. What will you do? I'm just interested in how you will work it. You can tell me how you would have worked that one. That the students are between. Clement.
So please, you're going to calculate from 56 under 57 to 67 under 68.
You're going to calculate from
56, the relative frequency, you are going to sum them.
Yeah, mention them.
So 0.0009 to
Mhm.
0.0735.
Very good. And you will add them, isn't it?
Yes.
Exactly. You will add them, and that will give you something like this. Okay. It will give you something like what you see here. If I want you to do that clearly, you'll get 0.9314. If you don't understand, let me know now. Now let's look at the next one. Okay. What is the relative frequency that the students are taller than 68 inches? Millicent.
So it will be from 0.0199 to 0.003.
0.0.
199, that's 69 and the 70.
It says 68.
Said they are taller than, so they can't be 68.
Yes, so, but
So
that is
69 under 70 to 73 under 74.
Is he mentioning the right numbers? Or maybe he's not seeing.
It says students are taller than 68 inches. So if they are taller than 68, then they should be 69 upwards.
I know. But I'm talking about the numbers you are picking.
Oh, yes, 0.0199. That's for 69 under 70.
Okay, good.
And then
Pache.
0.0003.
Pache, hand is up.
Yes, I think it should rather be Oh, the screen has changed. I think it should rather be from the 68 going down
What are you picking? Which
because
numbers?
0.0374.
Yeah,
Because between 68 and 69, they have values there that are still greater than 68.
that is why I'm querying her, and she seems to be on top of the game. She seems to know it all there. You know. Obin, was that what you were going to say as well?
Yes, please, Prof. Yes, please, Doc.
Yeah. I don't know. I don't really know what she was calculating. But if you check it, it's just what Clement said, or is it Kwache?
Yes.
They're just supposed to pick the 68, even including the 68 itself. The range above, 68 and under 69, all the way to the end. And that will be something like this. That will be something like that. And I've shaded that angle. If you do that and you add them, you're going to get something like 0.686. All right. So that was just a warm-up. Now, what did we look at? We looked at the height. Who can tell me under what circumstance can we say the height is normally distributed? Under what circumstance can we say the height is normally distributed? What makes it a normally distributed random variable, height? Well, it is because majority of people are around a similar height range. If you look at gender, it's binomially distributed because it's kind of two opposite extremes. But height, majority of people are even of the same height, and majority are around a similar height. Many people are, somewhere around 63 to 67 inches height. That makes height normally distributed. Okay, so what makes it normally distributed? When you take salaries, majority of people earn similar salaries, at least within a population. Majority, that is why we can calculate the average salary. And the average salary, majority of people are around that average salary. The same thing with weight. Most people are of similar weight size. So all of these kind of variables are said to be normally distributed. What does that mean? It means that the peak. So when you look at the distribution here, the peak is represented where majority of the people are. So if you look at 65 here, that is where majority of the people have got their height. And when you have a lot of people around up to, and then you have the left tail, which is on this section there, then you have the right tail, which is on that section. So it's a very, very beautiful concept, normal distribution. It cut across many random variables, many situations in real life. Now, the probability density function of a random variable talks about the entire space under the bell-shaped curve. And the cumulative density function talks about the additive values of each of these probability density functions. And these are written as what you see here. The sum of the probability density function add up to 1. And then, of course, you can see the integral of the cumulative probability density function. These graphs are just showing you an area or a portion of the area. Now, what is the area? I'll come back to you. See the area very soon. Okay, I'll come back to that. So what is a normal distribution? It's simply a probability density function reflecting empirical behavior of real life situations. Okay, and it is observed in practice. So it's something that we know most of the time. It was discovered by Carl Friedrich Gauss, and that's what led to the Gaussian distribution. It's also called a Gaussian distribution. It is a bell-shaped curve Very practical in so many things, widely used in many statistical analysis. And you can see a lot of examples. Many people have got a similar blood pressure level, similar shoe size, similar test scores, similar volume size. Of course, there are extremes, but majority, such things are said to be normally distributed. Very good. Now, the form, the way it looks like, is illustrated below, and I'm going to show you that below. The key point of what we are going to do today is to find the area under the normal curve. Now, you can see the difference between a normally distributed random variable on the left side, and then you can see that of an exponential distribution. Exponential distribution, the curve starts from the top and begins to fall asymptotically, towards the x-axis. In other words, it keeps falling and falling towards the x-axis, but it never touches the x-axis. That is what we mean by asymptotic. The normal distribution is beautifully bell-shaped. And you can see that I have greened one of the area. You see, the entire area is a space under the curve. And the green portion is the portion I am looking for. So if I have to find a portion of the area, I should be able to find it. Now, every distribution has a probability density function. And for normal distribution, this is the probability density function. The sigma there, the pi there, the mu, the x, all of them have got meanings. The key point is that you want a portion. I'll show you the mathematics, and then I'll show you the graph. Don't worry if you don't understand the mathematics. Sometimes somebody want to collapse if they see this mathematics. Just understand some few things here. Our interest, guy, let me just ask you something. What have I just drawn here? What have I drawn? And what have I drawn here? What is the one on the left here? What is the one on the left?
Rectangle.
A rectangle.
A rectangle.
A rectangle.
How do you find the area of a rectangle?
Length times breadth.
Length times breadth. Very good. Okay. Length times breadth or height. Okay. How do you find the area of a square? Oh, I was going to ask you, what is it? What is this? What is this?
A square.
It's a square. Somebody says, after my life. Now, what have I just drawn there?
A triangle.
It's a triangle. And what have I just drawn here?
A parallelogram.
A parallel. You know, somebody is sleeping as we have already started. The person has finished. He's finished his level. Okay. What about this? This is the one that begins to now measure something.
Trapezium.
Trapezium.
Hey, somebody knows, so somebody too is sleeping. What about this?
A rhombus.
Oh, you are good, man. This guy is just blatantly uncorrigible. He doesn't want to change. Very good, very good. Now, all of these you can find. Now, what is the last one here? What is this?
A circle.
A circle. Do you know that we can find the area of a circle? Do you remember the area of a circle?
Yes, pi r squared.
I thought you heard somebody even say it in my house here. Okay. So that is pi r squared. Now, what is the area of a triangle?
1/2 base times height.
Half base times height. Very good. Half base times height. Now, the same way we can have the area of this standard normal distribution curve, as you can see. What we know from what I've just taught you now, what we know is that the entire area will add up to what? The entire area will add up to what? You don't know. Or you should know. Because it's easy. Because we looked at it multiple times in this, and looking at the topic at hand, you can take a guess. the entire area will add up to what value?
1.
1. That was a good guess. And it is 1. The entire area itself is the probability. The entire area. You should write it down. Of a normal distribution curve is the probability. So now, let me take you back to this formula here. So the formula that you are seeing here, it is telling you the probability density function. You see, the word density is how deep something is. This is a function, it's a formula that helps you to know how deep. And to do that, you need to know the mean and the standard deviation. Of course, the square root of the variance is the standard deviation. You also need to know the pi, which is already known. It's 3.14159. It's general. It's just like the epsilon, the exponential function, which is usually 2.718. So these two you know. Once you know this, you can slot in. All you need is the mean and the standard deviation, and then you can do your magic, and you can find the probability density function. The particular continuous variable that you are looking for is usually the one with the question. And we looked at this the last time. It's the one that has the question. So this normal distribution, because it's bell-shaped, because it's symmetric about the mean and the variance, we can say that we can use it to determine the location and the spread of the distribution. The highest point of this curve is the mode. And as you can see, the mode will help you to determine the true normality. Okay, now I said that our interest is to find the area. And then somebody told me some few minutes ago that the area under this curve is equal to, the total area is equal to what?
1.
Which means that half of the area, when you look at the black line, the left part, half of that area is what?
Half.
0.5.
0.5.
0.5. And then it means that the other half is also 0.5. Of course, remember that as the standard deviation, okay, which tells you how wide apart it is from the center. The center is the mean, that's a mu. So the deviation from the center, so you can see that the deviation from the center here is wider than the deviation from the center there. Now, if you increase the deviation, it means that you are decreasing the spread. Okay? If you change the u, it will shift the distribution to the left. So that changing the mean will shift the entire green line. Okay? But this will flatten, changing the standard deviation will flatten, or it will pivot, okay, the entire shape of the distribution. But these are not the key point. The key point is that we want to know the area. Okay? We want to know the area under the normal. We know that the area itself is equal to 1. But what are some of the portions of the area? We normally say that X is normally distributed. That's how we write it with a tilde sign here. X is normally distributed with a mean of mu and a variance of sigma squared. Of course, you would have known the values by then. Sometimes if you don't want to use the variance, you use the. So our goal is to find the area. And I just said some few minutes ago that the area is also the probability. Write it down. The area under the normal curve is also the probability that we are looking for. So look at the area under the normal curve, whether it is less than or equal to a particular random continuous variable. The area under the curve happens to be the probability. So if I want to say that the probability of a particular range of values, all I got to do is to measure the area under the curve for that range of values. For that range of values. You see, the entire area is here, but this particular point or value is x naught. So if I want to know the entire area, which is the shaded part, I am just looking at, first of all, what will be the value here? What will be the value of the left side?
0.5.
0.5.
0.5. So I just need to know this other part here, okay, this other part here, and add it to the 0.5, and then that will give me the entire shaded area, which is also the probability. Don't forget. That means that the entire shaded area is going to be 1, okay, and the probability is also going to be 1. Now look at these areas. I'm giving you some samples before we start. If you want to find, now before we start this, take note of this, and this is critical. You always start looking for the area from the center. See, anytime you are you want to find an area, remember that the area that has been given you started from the center going to the left, okay? And the other area also started from the center going to the right. That is how you always read it. You read it starting from the center going to the left, or starting from the center going to the right. Okay, so if I tell you that I want you to tell me the shaded area here. In other words, I want you to tell me the probability that this particular random variable is less than B. You see, when I say it's less than B, I'm looking at the entire shaded area here. In other words, everything on the left of B. How do you find that? First thing you got to do is to find 0.5, which is a half of the area. Then you will add it to, now here's a point. You add it to the probability that this random variable is equal to B. Now watch the way I wrote it. The probability that this random variable is equal to B. Now why? Because the half of the area is already 0.5. The other half of the area is B. Now, how do you get the B? You started from the center and moved to the right. So this is the shaded area you are looking for. So this shaded area becomes the area that you are looking for. Once you get that area, you add it to 0.5, you have found the entire area. I've just explained it. Now, can you explain to me, how do you think I will get this shaded area here? This turquoise, turquoise, is it turquoise or turquoise? Oh, this color. How do you find this area? First, you will start once again from the center. Remember, this time you don't need the white area on the right, so you don't need 0.5 anyway. Okay. We are rather looking for the area below the A. So the probability is written as probability that X is below the A. Now, how do you find that? Well, I told you that we normally start from the center going to the left. So it means that I need to find the probability that, okay, the probability of the area before the A. So we need to find the probability of X is greater or equal to A. Or S is greater than A. Other one. See, once you find this, you subtract that from what? Who can tell me?
The 0.5.
Excellent. You subtract that from 0.5. So your answer is going to be 0.5 minus the probability that X is greater than A. And that will give you the probability that X is less than A, which is what we are looking for. Okay, I think you guys get it. So who can tell me how to find this last one? Who can guess and tell me how to find this last one? First, you got to pick it one by one, actually. Then you will know. So first, what do you have to find? You have to find the probability that X is what? Because remember, the area we are looking for here is both the red and the blue. Both the red space and the blue. And then we know that the red space plus this white space there add up to 0.5. And the blue space plus this white space here add up to 0.5. Okay, but we're not looking for all the space. We are just looking at this. And we know that we always start from the center towards the left or the center towards the right. So what will I find first? Probability that X is what? X is equal to, as I find, if you're going direct. Oh, hold on. That means that this point I just gave you here, guys, it's not supposed to be greater or equal to. It's just supposed to be X is equal to A. Okay, it's supposed to be X is equal to A. That's how you read it, because you're reading it from the center. The one I gave was like both this space and that space. We're not looking for that space. We are looking at just this left space. And so it's supposed to be X is equal to A. Take note. So this same one, you're going to find probability that X is equal to what? A. Then you add that to the probability that X is equal to B. Watch it. Because I'm starting from the center and moving to the right. And I'm starting from the center and moving to the right. So once I find the red shape, the red area, and I find the blue area, I add the two, because that's what it is shaded. Anything that is shaded is what you're looking for. And then you sum the two up. Remember, these are probabilities. So the values are going to be below 0, below 1, and above 0. Okay, I think an example will do. All of this might be mumbo jumbo, very abstract. Example is more efficacious than present. Let's take a typical thing. Before you can ever find the probability, I want you to write something. Okay. I want you to write what I'm about to write. It's very important. You need to know the random variable, and then you will use the random variable to find the z value, and you use the z value to find the area, which is a probability. What is this z value? The z value is a way to standardize any value to the standard normal distribution. You know, sometimes we talk about a standard. For example, these days, if you want to standardize your currency, you match it against which currency?
A dollar.
A dollar.
USD.
The same way, any number, any normal distributed number, with a mean, with a variance combination, any can be transformed into the standardized z-test. Because the z-test has got a zero mean and a constant variance. And so you can take kilograms, dollars, pounds, height, gallons, barrels, and convert any one of these into the standard normal, value. And then once you have done that conversion, you can now use that standard normal table to find the probability you are looking for. That requires you to find a formula for the z table, and the formula is what you see down here. This is a z value formula that can be used to convert any standard, any random variable to the standard normal distributed variable. And so you got to know this formula and use it to do your conversion. Okay, so that's what we'll do pretty soon. And like I said, in order to do that, we are going to start a typical example case study. This is an exam case study. Bogas, are they still existing? Or they are not there?
Yes, they are.
Yeah, there.
Yeah, on the spin.
Okay, who can read the first bullet for us? Feel free. Am I on? Easy.
I will.
Okay. Polar sells furniture and carpets. From years of sales records, management has found that the mean number of yards of a carpet demanded by customers during a week is normally distributed 4,200 yards, and the standard deviation is 1,400 yards. 1. The store manager wants to know the probability that the demand for carpet is in the upcoming week will exceed 6,000 yards.
Let's stop there. Anytime you get a situation like this, you remember the last time we looked at binomial and Poisson, I told you something, that when you have question about binomial, Poisson, and all of them together, there must be a way you can detect that this thing is Poisson, this thing is binomial, and this is normal. For normal distribution, it's easy to detect. Why? Because, and pay attention and write it down, you will always be given the mean and the standard deviation. Take note. You will be given the mean and the standard deviation. You'll be told that is normally distributed, but the thing is, even if you are not told that is normally distributed, you will be given the mean and the standard deviation. You will have a way to find the mean and the standard deviation. And that is a beautiful point there. So the first thing you do is to document that information. So in this our example, what is a mean and what is a standard deviation? Remember, all of them require that you use a formula up here. And you can see that in the Z formula, you have the mean, you have the X variable, you have the mean at the top right, you have the standard deviation at the bottom. So in this question, what was the mean? Yeah, DAPA.
The mean is 4,200.
And
the standard deviation is 1,400.
Now, the first thing you have to do is to draw. Draw what? Draw what the question is asking you. Because now when you come to the question number 1, it says that the manager want to know the probability. So we are looking for P. The probability that the demand for carpet next week will exceed 6,000 yards. The word will exceed is very important. And the 6,000 yards is important. Now, this 6,000 yards, according to the Z formula, will be represented by which letter in the Z formula? What do you think will be the 6,000 yards? Which variable would that be? Sorry, which variable would that be?
The X variable.
It will be the X variable. And so, well, the first thing you want to do is to draw the entire story. That's the first thing. Draw. Draw the information that you have been given. How do you do the drawing? Well, before we do the drawing and analyzing, remember that you have been given a Z table, and I've sent it to you as well. So you all have it now. So you should open the Z table now. The next thing now is to identify the elements. So we've already established that the mean is mu, which is what? 4,200 yards. So you write it down nicely. The standard deviation, which is sigma, is 1,400 yards. 1,400. Now, the next thing is to draw for the X value. And she said that the X is a 6,000. So first thing to do is to draw a normal distribution curve like this. Then in the center, you indicate what value?
4,200.
4,200.
4,002. You write that. All of these will be marked. And below that, you write the standard deviation always. Then you ask yourself in the question itself that this 6,000, based on the language, is it going to be to the right or to the left of the mean? You can tell us.
To the right.
It's going to be to the right.
It will be to the right. So you just identify any portion to the right. Let's call it somewhere here. And then you will write the 6,000. That is actually the x. You can even write x equal to 6,000. So that is the x variable that you are. And the question says, what is the probability that upcoming week demand will exceed this value? So looking at space A, space B, and space C, which one are you going to shade to represent that question? Which space? Raise your hand. Which space are you going to shade to represent this, Andrew? Andrew.
You said 6.
Why?
Because the question is saying they are expecting to exceed 6,000 yards. So we expect that the figure should be more than 6,000.
If it had been, we want whether demand will be no more than 6,000 yards. Where will you shade? Anybody? Raise your hand and tell me. Where will you shade if it has been demand will be no more than 6,000 yards? AC.
Did you shade A and B?
What if he has said that demand will be less than 3,000 yards? Let me see whether there's a smart one here. Demand will be less than 3,000 yards. So only shade. Mercy.
No, please, I'll shade A.
You cannot shade A. You can give me another answer. Demand will be less than 3,000 yards. Valentine.
B.
No, you cannot shade B. Someone. I mean,
Please, Doc, I will shade the end edge of A. I will
exactly.
create another column like, yeah.
Exactly. You have to create another column here and then shade this section. Why? Because you are looking at less than 3,000. Okay, so first you got to create a column called 3,000, which is on the left of this, before you shade it. Guys, this is the real deal. This is a real deal. Very good. Don't worry. I know that people I'm going to be giving marks eventually, so you don't need to worry. So now let's look at how we can address the first question. Let's go to the 6,000 yards. So now we identify the area in question. First, we got all of the elements. This is the shaded area for the 6,000 yards. You can see it nicely there. Once you've identified the 6,000, now you need to use the Z formula to find the 6,000. What is the formula? I want each one of you to do that and then raise your hand and tell me your Z value equivalent to that 6,000. Given all the other information you have been given, because you've been given the mean and then the standard deviation. Who can tell me? What is the Z equivalent value for that random variable? Yes, Adam.
1.285.
Oh, good.
1.286.
Always correct it to 2 decimal places.
Okay. 1.289.
2 decimal place.
That will be 1.289.
2 decimal place. Philip.
1.29.
1.29.
Master, I told you to eat. You remember? So that's it.
Yes.
What he just found is here. Okay. That's the one he just did. So you're going to put it into the formula here and you get 1.29. Now that means that this 6,000 is 1.29 standard deviation from the mean. Now, we have been able to use the random variable x to find the z. And the z is 1.29. We're going to now use the z to get the probability. And how do you do that? This is where you use your table. So go to your table. And I'm going to show you what to do. First, you're going to see that this table, you're going to look on the far left of the table, and that is the Z value, starting with all the Z values. So this value, for example, is 1.1. Okay, that is one decimal place. But what if it is 1.14? How would you have picked the value? Now remember that 1.1, the values must always be in two decimals. So 1.1 is actually 1.10. And 1.10, this is how you read it. You read this 1.1 under 0, and then you come and pick the 0 here. That makes it 1.1 under 0. What if it is 1.14? You read the 1.1 under 4, and under 4 will be here. So you come and pick the under 4. If it is under 7, you pick it here. The 7 is gone up, but it's there. And if it's under 8, you pick it here. And if it is under 9, you pick it there. So on the basis of this, what will be, what value? And when I say you pick it there, you read it. You read it where it matches the one. Okay, and then you pick the probability value or the whichever. What will be the probability value for 1.29? Who can tell us? How you read itself is a skill. It's a marking skill. So how will you do that reading? Paris?
Okay, so you pick on the left hand under Z, you pick 1.2, and then you go to your right and under 0.09. So then the value for P will be 0.4015. 0.4015.
Very good. So guys, what he said is that you will pick your value. Okay. You pick your value first, you pick the 1.2, which is right here. And then you pick under 9, which is right here. And then where the two meet, okay, you keep going to the right, going to the right, going to the right until this final part. That is a matching point. It is 0.4015. That is your value. But you should understand that what you have actually read is, watch it, what you just read is actually the space, which is the white space. But what you are looking for is a shaded space. Remember that I told you that whatever you read on the table is starting from the middle. So the area you just found was the 0.4015. That is this white area. But the area you're looking for is area above 6,000. So how will we find this final blue shaded area? You can tell us. How would you find it? Vera.
So please, we'll have to subtract this from 0.5.
From
0.5.
And what will you get? Why, you didn't know I was going to ask you that?
No, I'm not having my calculator. Please just come on.
No reason why I asked you. Because you cannot be in my class and say that you are not having a. In fact, you shouldn't even have voiced that out. Voicing that out is showing your lack of knowledge. You shouldn't have mentioned it. Yes, Millicent.
0.0985.
That's it. Okay. So when you work it out, you're going to get 0.0985. Okay. In percentage terms, that means that the chances that next week we are going to get, demand for carpet to be exceeding 6,000 is quite slim. That's what it means. The chances are very, very slim. Why do we say they are very slim? Because it's not even up to 10%. It's just 9%. But does that make sense? Of course, because you know that the average, we were told that weekly, carpet demand was what? 4,200. So to actually tell me that next week is all of a sudden things are going to change dramatically, it is too far-fetched from the mean. Above 6,000. Above 6,000 in demand for carpet can even be 1 billion. That's why the chances are very slim. That is how you work that. Now, the next part of the question, if you have a question, you can ask. The next says that what is a probability, and it's on the screen here, what is a probability that demand for carpet will be 5,000 or less? I actually didn't use that exact word. So I want to take you back to the exact word. It says that what is a probability? Oh, yeah, it's exact words. The demand for carpet will be 5,000 yards or less. How will you shade? How will you draw it? 5,000 yards or less. How will you draw it? Looking at the mean, looking at this mean, where will the shading be? Of course, we know 4,200, we know 60. Where will the shading be? Your explanation is what I want, and I know your explanation I will understand. Marilyn.
So it will be between the mean 4,200 and 6,000. We'll make a mark between that.
And
then the area between the 4,000 and the 5,000. Sorry, Doc, I didn't hear you well.
I'm saying, and then your shaded area will be?
The shaded area will then be between the 4,200 and 5,000, and between 4,200 and less than that, that whole area backwards.
Exactly. I understand the language you're speaking. Okay. So that is exactly what will happen. So she's actually going to create a 5,000 plot here. Okay. Please remember to always label, and then you shade all of the area here. How will you work it? If you were to work it, how will you work it? Given all that we've said, how will you do the working? Okay. First thing, you are going to find the Z value for 5,000. Everybody find that. You're going to find the Z value for 5,000. Kwachi, what did you get?
0.57.
Kwachi, you're like a jet plane, eh? Yeah, I like that. I like that. You see, the thing is that if those who don't understand don't ask, then you who understand should just keep talking. I love that. So that is a good answer you just vomited out to us. So guys, you're going to get 0.57, correct, to 2 decimal places. 0.57. What do you do with this 0.57? What do you do with the 0.57?
Go to the table.
You will go to the table and read it. I want you to take your table and read that 0.57. Read that 0.57 and tell me. Remember that this 0.57 is moving to the right. Millicent.
0.57 is 0.2157.
Good. What do you now do with that? Millicent.
We'll add that to
Andrew is waiting for
we'll subtract, so 0.5 minus that plus 0.5.
What are you saying plenty like that? Yes, ma'am.
You add that to 0.5.
That's it. You just add that because remember the question was, and it's at the top of your screen, 5,000 K or less. So 5,000 K is from the center to the right, or less is all the 0.5. So when you now get that, you add this, and you're going to get 71.57%. What does this mean? Who can interpret? Because your interpretation is very important. It's always 6 months. It's important you know how to interpret. What does this mean? Practical sense. Someone.
It means there's a 72% chance that demand will be more than 5,000, will be less than or equal to 5,000 yards.
Are the chances high or low? The chances here, are they high or low?
High.
Very high.
They are high.
Why do you believe it's high? Why do you believe it's high without looking at the 72%? Why does that make sense? That's what I mean. Why does that make sense? That you have a 72% chance. You see your hand is up. Obin.
Hello, Doc. Because the probability chance the demand will be less is about is high. 70% is high. So when the demand is the market, when the demand is lower than 70%, they will not be able to get profits. They will get loss.
We haven't spoken about profit or loss here. Opele chinkafe. Opele, there is no profit or loss matter here. Marilyn.
Okay, so just even looking at the diagram, and the probability is the area under the shaded portion under the curve. A greater portion of that is what is shaded. So that shows that there's a higher probability that the demand for the lesson will be okay, it just shows that the area under the curve, that is the probability of the demand being less than 5,000, is big. So it shows that
so it's all based on what? Based on what you say, it's all based on what?
The area under the curve.
So just looking at the area under the curve alone is the reason why the probability must be high.
No, it is closer actually. So in this case, looking at the mean is 4,200. Looking at the space, 5,000 is a little bit above 4,200, and it's also everything below the mean. So
now you're talking properly. Now you are expanding the point. The key point is that the value is around the mean. That's the key point. The value is around the mean. The value of the entire shaded area is around the mean. If it has been above, if it has been above 5,000, do you think the probability will be more or less? Will it be more than the 71 or less? I mean, you should think about it. You know, I'm not looking for the answer, but you can think about it.
Less.
Okay, the next one is the demand is between 3,000 and 5,000. Okay, 3,000 and 5,000. Now, you guys have worked everything. I want you to work that one and tell me. Demand is between 3,000 and 5,000. Solve for me and tell me the chances that demand will be between 3,000 and 5,000. Let me give you some few minutes to work it out. I want to see whether you can actually learn from all that we are doing so far. I'm waiting for who has been able to crack the code of statistical dynamics. So you will notice that when you work it out for the 3,000 and 5,000, first of all, we have already calculated that of the 5,000. So we know the value. 3,000 will give us negative 0.86. Negative 0.86 doesn't mean that you should look for negative in the Z table. It simply means that you should take the absolute value, because a normal distribution curve is a mirror image of each other. And so you take the absolute value. We've already read that of the 5,000. We are going to read that of the 3,000, which is a z-value of 0.86. When you go and read 0.86, you're going to read 0.8 under 6, and that will give you 0.3051. Okay, if you check your table, you should see. If you check and you don't get it, let me know. So now we've gotten the 2. Remember that the 5,000 would have given us 0.3, it will give us 0.2157. And then you add the other one to it. You add the other one to it, and that will give you a value of 0.5208. So that is the gap between the two. Remember, when you read both of them, you add them. You don't need to subtract any one of them from 0.5. It's just a direct approach. So now you have learned clearly how this thing works. But how does it work in Excel? How does it work in Excel? So you can check your Excel I gave you. I'm just going to use mine here, but you can check yours as well. Yes, Ishmael.
Sir, can you please go back to the previous slide? I just want to pick something briefly, sir.
Yeah, I'm there.
Okay. Okay, all right. Thank you, sir.
So now we are going to take a typical example of this using Excel. You just have to know how Excel actually works this. Manually fine, but you have to know exactly how Excel is also doing this. So I'm going to go open this Excel. You can follow me through. And this is a binomial chart. I've just drawn, and again, you have it, so you can look at mine. Let's remind ourselves slightly of the nature of the question at hand. The question was, the distribution of customer demand every month is normal, with a mean of 750 and a standard deviation of 100. I told you should always use a mean and the standard deviation. Okay. So here you have this data point of X. Let me just give them some colors. And this column with yellow, 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 these are you calculate the mean, and if you check carefully the mean, when you use your formula, the average is going to be 700. Okay. The question says that it has a standard deviation of 100. Now, the standard deviation has been given to you. It's been populated to you. You are not finding that. And then you are told to find the following. The first thing you are told to find is to find the probability that demand is at most 900. At most here means what? What symbol is at most?
Less than or equal to.
Very good. Less than or equal to. So now you go to your formula, okay? And first of all, you have to find the probability for each one of them. How do you do that? Use this normal dot distribution formula. And that normal dot distribution requires you to know the value of X. Now, so here, when you pick on this, watch the formula. Normal dot distribution, the value of X. And when you look on the left here, the value of X is what? It's 500. So A5. Then the mean. The mean is the one up there, 750. So that is cell B2. So you select B2. And then the standard deviation is 100, which is in cell B3. So you select B3. The last one is a cumulative probability density function. We don't need that, so you select false. If you need that, you select true. Now, we are looking at f of x, so we don't need that. But when you look at the next one, capital F of x, that is the cumulative. And so that one, when we get there, it's true. So you click enter. And then, oh, by the way, remember that when I selected the B2 and B3, you have to press the FN key. You have to press the F4 key. And the dollar will come between, in front and behind the letter B. It will come in front or behind. You have to press F4 key. Why? Because when you press the F4 key, you attach the formula. So even if you go to the next cell and the next cell and the next cell, they will all be collecting the 750 and the 100, which is the B2 and the B3. Automatically, they'll be collecting them. So you don't need to type it again or do anything again. So once you click enter, you're done. In fact, I can delete everything here. Can delete everything here. And then once you've done this, you just click on the bottom right and double click Papa, and it will populate everything for the other formula because of the dollar symbol that you used. That is how you get the probability, density function for each of these values. And then this also gives you the cumulative. So cumulative, as you can see, I mentioned that is when you make it true. Everything is the same, you just make it true. When you make it true, as you go to the bottom, even if I delete this information, and I keep going. Once I do the first one and it's correct, I now click on the thing, and then when the cursor turns black, I double click Papa, and everything is populated. And you can see that the cumulative probability is going up towards 1. And as it gets towards 1, it increases from the first until it gets towards 1. Any question? So that is how you find it. Now, on the basis of let's look at the question. The question says, after you found the probability together with the cumulative, the question says that at most 900. So when you go to this section, where is at most 900? At most means that everything all the way up to what? 900. But I'm using the cumulative. So basically, you're just picking this last one here, 0.9332, because it is the cumulative value of all the individual. It is actually this one that when I pick all of them up to here, I get that. But you can see this on the, when you are taking a cumulative value, you can see all of them as you keep adding that. Okay. The next one is, so that's at most. The next one is exceed 700. What does the exceed 700 mean? Okay. Now, the exceed 700 here means that you are looking at anything above this 700. And then you sum them up. So what is the first thing that exceeds 700? 500. 0.69. These are the cumulative. Okay. But you are not looking for that. You are looking for those that exceed 700. So you are going to pick on all those, because it says at most. Oh, sorry. Okay. So when you look at 700, it is this one. Where is that? Yeah, this one. Watch the formula there. Okay. This is thing 700. I think it's supposed to be exceed 800. I don't know why I chose exceed. Yeah. No, I don't know why I chose. It's supposed to be exceed 800. It's supposed to be exceed 750. That's how it's supposed to be. Exceed 750. Or better still, up to 750. Up to 800. And that will give you this value. Up to 800. That will give you this value. And then the last one says is between 700 and 900, okay? 700 and 900. So those are what I have here. 700 is what? 0.385. 900 is 0.9332. So you just take the difference between this, because I'm taking the cumulative value. So you take this 0.9932 minus 0.3085. Okay. When you take the difference between the two, you're going to get something like this. 0.9932, 0.3075. That'll give you 0.6247. So basically, you can use, the only thing I'm just saying is you can use Excel to run your distribution. And let's go to the last thing. And the last thing here, and the last thing on this part, is finding the X value if you have been given the probability. Let me just remind you. I told you that you use the X to get your Z. Then you use your Z to get your probability. What if you go backward this way? What if you keep rather going backward? What if you rather have the probability? You got to use the probability to find the Z. That's change of subject. And then use the Z to find the X. How do you even identify that question? Well, one way you can identify that question is when you have been given the probability, the percentage, the area. Let's take an example. First of all, to move from Z to X is easy because we were able to move from X to Z using the formula, the Z formula. So we can use this same Z formula, rearrange it, and we can find the value of X. At first, it was Z that was on the left-hand side. But you can now use change of subject to find. Why? Because it was like this. It was Z equals to X minus mu over sigma. So you cross multiply. Okay, so that will become Z sigma equals to X minus mu. You want X, so you make X the subject. So that means that you're going to have Z sigma plus mu equals to X. And basically, that's what you're having right here. Okay, that's exactly what you're having in this sheet. Okay, so let's take an example. This is tricky, so pay attention. If you haven't been paying attention, this part you have to pay real attention. Suppose the price of wache is normally distributed with a mean of 8 cedis and a standard deviation of 5 cedis. First thing to do is to draw. So you do your drawing nicely. This is a normally distributed curve. We are told the mean is what?
8 cedis.
8 cedis.
So you write 8 cedis directly below. And then the standard deviation is what?
5.
So you write 5 below. Now, normally, when we are finding the probability, we are also giving the X. But this time, no. The question says, now, find the price of wache. Now, remember, he started with, suppose the price of wache is normal. He didn't tell us the price of wache. So that price of wache is the random variable. Okay. But we know that it's normally distributed. Now, I want you to pinpoint that particular price so that what? Only 20% of all wache prices or all wache prices are below this price. Which price? The price you don't know. Now pay attention. Because if you don't pay attention, when I finish, you will tell me that I should go right again. So you are told that you should find a certain price. Now, right now, I don't know where the price is. The price itself that we are looking for, that price could be to the right of 8, or it could be to the left of 8. It is a price along this line. I just don't know. It's a random variable. It's a price. Just as 8 is a random variable, but it's the mean of the random variable. I don't know that. But we know that the value 7, will it be to the right of 8 or to the left of 8? 7.
To the left.
To the left of 8.
What about 12?
Right. The right of 8.
The right.
So we know, but we don't know which of these prices is going to be and whether it's going to be on the left or. So we need to find. But there's a clue that we have been told that only 20% of all wache are below this price. Hold on to the word below. But let's focus on 20%. The entire percentage from left to right is how many percent?
100%.
Very good. So if it is 100 and you're moving from left to right, that is capturing all the 100, 20, will it be to the left of the 8 or to the right of the 8?
To the left. To the left.
To the left. That's a first good point. So you identify a line, let's call it somewhere here, and then you put a question mark here because we don't know that X value. But we know that the area for that is 20%. So in this case, this 20%, is it going to be in A, in B, or C?
In A.
A.
Very good. I agree with you. So this 20% is going to be EA. So let's shade it properly there. Okay. So we know that here is 0.2. We know that. Okay, cool. Now, that means that we know that this area is what?
0.3.
0.3. Keep that in mind. Now, anytime we are looking for a particular junction in the X, if you could remember, we normally will start from the center and go leftward, isn't it?
Yes.
Which means that which value are we actually reading? Are we normally reading the 0.3 here or the 0.2?
0.3.
Which value are we using to find the Z?
0.3.
0.3.
Yeah.
Exactly. So even though you have been given the 20%, what you are actually reading because of the movement is the 0.3. Okay, so now we can confirm that our probability value is what? 0.3. Okay. Oh, wow. So now we don't have probability value. But we also said that once you know the probability, this time you can use it to find the Z, and then you can use the Z to find the X, which is what we are looking for. But this probability 0.3, is that exactly the value? So you go to your Z table. Let me see what I can get a Z table without moving away from here. You're going to go to your Z table. Let me see if I can get one Z table. So this that you see on the screen is a Z table that I just found, which you also have. Okay. So look at this Z table. We are looking for a number or a certain numbers closest to 0.3 because 0.3 is a probability. Remember, the probability are all the numbers in this big space. The Z values are those that are on the edges, if you can remember. When we're looking for the Z values, we're picking them at the edges, then matching them with the top. But then these probability values are those in the swimming pool. So you're going to comb this entire swimming pool and look for a number closest. And closest is a very underlying word, 2.3. Now, which number? The term has been arranged in such a way that they are climbing. You can see 1, 1, 1, 1, 1, 1, 1, 1, 1. Then 2, 2, 2, 2, 2, 2, 2, 2. Okay. Which number is closest to 0.3000? Watch it.
0.2995.
Very good.
Which
So,
is so the Z is the 0.8.
Hold on. I'll come back to that. That's not how you learn. That's how I teach. I'm teaching you, I learn. So you look for the number 0.3. Now, there are two numbers that match here. One of them is 0.2995, The other is 0.3023, which is the closest to 0.3. Well, if you want to know which one is the closest, you only subtract both of them from 0.3. And then you see that the one with the smaller absolute value, that is the one closest. And that is what? 0.2995. So now that you've gotten the 0.2995, you can now find its corresponding Z. So now we are back to you, Pache. To find the corresponding Z,
Yes.
what to do?
So that would be 0.8.
No. To find the corresponding Z, what do you do?
Okay, so we look at where the 0.2995 end is, then we just check at the left-hand side. We trace it to where the Z values are, and we see that it corresponds to 0.8. I also look upwards, and we see that also corresponds to 0.04.
Good. Guys, if you don't understand, yes. So the number will be what?
So the number will be 0.804.
Say it again.
0.84.
0.84.
Sorry, 0.84. Sorry.
However, this number would have to be negative. Why? Let's go back to the
Because
X.
it's to the left. That's not on it.
So when you go to this thing, you will see that it is to the left of the mean. It's to the left of the mean. And anytime, this is a symmetric shape. Anytime the number is to the left of the mean is negative. Anytime a Z value is to the right of the mean, remember I'm talking about Z value here, it is positive. And since this one is to the left of the mean, it's actually going to be negative 0.84. That's it to get. Everything I've said is here. So we got 0.2995 or 6. Okay. And then I indicate normally how to get it. And then I asked the question, why is it negative 0.84? And the answer she gave was because it's to the left of the mean. Okay, so now that we got it, we can now use this to find our X. Because what is it? The X value is equal to, the Z value is equal to X minus the mu over the sigma. And we don't know the X, so it will be X minus the mu. We know the mu to be what? 8. The standard deviation is what?
5.
5. And now we know the Z value to be what?
Negative
0.84.
See, at this stage, if you don't add a negative, you'll be in trouble.
Hey.
So that's why you got to know why it has to be negative. That's why you got to draw in the first place. So now, let's substitute. Let's cross multiply. You're going to cross multiply, and then you're going to find that the final price that you'll be looking for, because you know exactly. And you see, at the end of the day, the final price you're looking for should be less than the mean. Okay, let's check. You substitute that, and then you see that the final price is 3.8. So when you go to the mean, which is 8, 3.8 is actually to the left. And these are random variable, not the Z value. Remember the Z values, they are negative. But then its corresponding random variable is positive. That is the answer you are looking. So what does this mean? This means, because if you go back to the question says that tell us the price. Let's go back. It says now find the price of Wache so that only 20% of all Wache prices are below this price. So when you take the price of Wache, which is 3.8 Ghana cedis, 20% of all Wache prices are below 3 cedis 80 pesos. They are below. 20% are below, which means that how many percent are above? 80%. Eighty percent of the prices are about. So that is how it's supposed to work. This is how you execute, how to move from the probability value towards the X value. Now, let me just give you another one because this is a bit tricky. Imagine the thing has been 40% of all the prices are below this price. What number are we going to find? If it has been 40% of all prices are below this price, what probability are we going to read? Let me just draw. Okay. Suppose you have the 8 and then 5, and you are told that 40% of all the prices are below this price. Just as we search for the 30, what are we going to search for? Mommy? Boya, lights no, I'm on the